You kind of get the feeling, right? AI is just, well, everywhere these days.
Yeah, absolutely.
From like simple web searches getting better to potentially, life-changing things in healthcare. It's moving so fast. And if you're like me, you're probably thinking, okay, what do I really need to grasp here?
You've absolutely hit the nail on the head. And that's exactly what this deep dive is all about.
Right.
We've sort of waded through a pile of information articles looking at the newest AI hardware, a good overview of AI itself, and reports looking ahead, including everything from NVIDIA's big GTC 2025 event.
Exactly. So the mission today is, well, simple. Cut through all that noise. We want to give you the key takeaways, where AI is right now and where it seems to be heading pretty soon. We're talking the building blocks, the hardware.
The real foundations.
Yeah, what that hardware actually lets us do and, the big trends shaping the whole thing. Okay, so let's unpack this, starting with the core, right? The AI hardware.
Yeah, think of it as the engine powering this whole AI revolution. And right at the heart of that engine are these specialized AI chips.
Okay.
And it's a really competitive space. We've seen some pretty big moves lately. There was a good TechTarget article covering a lot of this.
Right, I saw that. They pointed out some really interesting stuff like Alphabet. They're not just doing search, right? They're pushing into quantum computing.
Yeah.
This Willow chip.
Yeah, the Willow chip.
105 qubits, apparently. Designed for scalability, less errors in those super complex quantum calculations.
Yeah.
That's pretty advanced stuff.
It really is. And what's interesting is Alphabet keeps exploring these different ways of computing. Quantum's still, early days.
Sure.
But investing in it shows, I think it'll be vital for tackling the really, really tough problems down the road. It's a long game they're playing, pushing the boundaries.
And maybe more immediate, AMD's been busy too. They launched their Zen 5 CPU architecture, the Ryzen 9000 series, late last year.
Late 2024.
But for AI specifically, their Instinct MI300 chip, especially the MI325X that came out in 24, it's got, 6 terabytes per second of memory bandwidth? That sounds like a lot.
That is a ton of bandwidth, and they're not starting. The MI355X is slated for 2025. They're clearly taking aim at NVIDIA's Blackwell.
Right, so this competition, it basically means things get better and faster for us eventually.
Exactly. AMD is positioning itself as a strong alternative, and that focus on memory bandwidth, it's critical. AI models chew through massive amounts of data.
Okay.
Think of it like having wider pipes, to move information to the processors faster. The faster you feed the data, the faster the AI learns and works.
Makes sense. Then there's Intel, the name we all know from CPUs. They're making big AI moves too. Their Xeon 6 processors started shipping to data centers in 24.
Yeah, and the core counts are just staggering, up to 288 cores per socket.
Wow. That's huge parallel processing power. So the takeaway isn't just the names and numbers, but this relentless push for more power, right?
Yes.
More specialized chips.
Absolutely, which unlocks more complex AI down the line. And Intel's leveraging their history, but also pushing with their Gaudi 3 GPU chip. What's interesting there is how they're comparing it directly to NVIDIA's H100, claiming it's like 1.5 times faster for training and output using less power.
That's a bold claim.
It is. But they also canceled their Falcon Shores project, which might suggest a bit of a strategy shift, maybe more integrated AI stuff long-term, not just standalone accelerators. Though Jaguar Shores is apparently still coming in 2026, so they're definitely still in the accelerator game.
Okay, so connecting all this hardware stuff to what AI actually needs.
Yeah.
Jensen Huang's keynote at GTC 2025 really hammered this home. He talked about agentic AI.
Right, the idea of AI that can reason.
Yeah, and he said AI that can really reason needs something like 100 times more computation than we thought. That's just mind-boggling.
It is a huge leap. Agentic AI, these systems that don't just understand, but can reason, plan, act on their own, it just inherently needs vastly more compute power.
Like the difference between GPS directions and a self-driving car.
Exactly. That gives you a sense of the jump in complexity and the compute needed for this kind of agentic AI.
And NVIDIA, obviously the leader right now, they're not slowing down. They announced Blackwell, claiming 40 times the performance of Hopper, their last gen.
Yeah, a 40x increase, and it's already in full production.
And they're already teasing Blackwell Ultra for later this year, and then the Vera Rubin architecture planned for 2027. Promising. What was it? Extreme scale.
Extreme scale up, yeah. That term is key. Huang talked about an annual rhythm for AI infrastructure, meaning new GPUs, CPUs, accelerators every year.
Wow, an annual rhythm.
This crazy pace is just fueled by AI models needing more and more power. It's almost insatiable.
He even gave examples of the scale-up, like the NVLink 72 rack for Blackwell. Sounds like data centers are getting incredibly dense.
Super dense, super interconnected.
And he mentioned something technical, disaggregating prefill and decode in reasoning models. What's that about?
Yeah, it's technical, but the basic idea is efficiency. Think of prefill as the AI taking in the info, getting it ready.
Right, yeah.
And decode is generating the actual response. By splitting them, they can optimize how resources are used in these massive AI centers. Makes things faster, more efficient.
Right, fine-tuning the process.
Exactly. That level of control gets more important as the models get bigger and more complex.
And managing these huge AI centers. Huang mentioned the operating systems, pipeline parallel, tensor parallel, expert parallel, in-flight batching, disaggregated inferencing.
Yeah.
It sounds like just running the place is a massive job itself.
Oh, absolutely. It's like conducting a giant orchestra. Highly orchestrated, sophisticated software coordinating thousands of processors working together on one complex AI task, every instrument playing in perfect harmony.
Okay, so hardware is racing ahead, just trying to keep up with AI's demands. But what does all this power actually do? Like in the real world, what applications, what trends are popping up?
Yeah, this is where you see the payoff, right? The tangible impact. There's a report from Exploding Topics that had some really interesting insights on the big trends for the next few years.
Okay, what stood out?
Well, one huge theme is how AI is just fundamentally changing work.
How so?
They suggest that even with today's AI, we could automate something like 60 to 70% of the time employees currently spend on tasks.
60 to 70%, that's huge.
Yeah.
Are companies embracing that?
Surprisingly, yeah. It seems workplace leaders are mostly welcoming the shift. But there's another side to it.
Which is?
The report noted a massive jump in searches for AI recruitment, up nearly 500% in 5 years.
Wow. So demand for people who can actually build and manage this AI.
Exactly. It promises efficiency, but also creates demand for new kinds of skills.
Which I guess inevitably brings up bigger societal questions, like universal basic income.
That's definitely part of the conversation. Searches for basic income are also way up. Suggests people are thinking about what happens if automation displaces a lot of jobs.
Yeah, if AI handles a lot of routine stuff, how do we make sure everyone has a basic standard of living? It's a huge question.
It really is.
Okay, what other areas? Software development seems like a big one.
Oh, absolutely. Tools like GitHub Copilot, they're already generating almost half the code on the platform.
Half?
Yeah, and the prediction is maybe 80% by 2027. Plus, you have Google's Gemini Code Assist, Amazon's Q Developer. It's really changing how software gets made.
So AI as a co-pilot for developers, automating the grunt work.
Pretty much, freeing up humans for more complex, creative problem solving. Wayfair apparently used Gemini to speed up setting up their coding environments. Real world impact already.
That's a big shift. AI not just running software, but helping create it.
Exactly. Faster development, maybe totally new kinds of software design become possible.
Now, let's talk healthcare. Yeah. This feels like an area with massive potential. The numbers are pretty striking.
They really are. Goldman Sachs estimated AI could automate maybe 25-28% of healthcare professional work,
Leading to cost savings.
potentially $360 billion. For anyone worried about healthcare costs, this could be, really significant down the line.
Huge implications. Where are we seeing it used already?
Areas like radiology analyzing images, pathology identifying diseases, patient monitoring, even vaccine development, like with COVID-19.
Right.
And the FDA, they've already approved over 650 AI-enabled medical devices, mostly in radiology, which shows that field is kind of leading the way.
And looking ahead, precision medicine.
That's a huge focus. Tailoring treatments to individuals, and drug discovery searches for AI drug discovery are up over 900% in 5 years.
900%. People are clearly excited about using AI to find new medicines faster.
Absolutely. And it's not just hype. Companies like Verge have an ALS drug in human trials. Exscientia has several drugs in trials too.
So, real progress.
Definitely. And big players like NVIDIA and Pfizer are investing heavily in companies like Cytoreason. It really validates the potential to revolutionize drug discovery.
Okay, so work, software, health. What about creativity? Filmmaking came up too, right?
Yeah, AI is unlocking new creative avenues there. Tools like Runway, Sora, Mind Studio, they're making content creation faster, cheaper.
How much cheaper?
Some suggest it could eventually cost less than 10% of today's production budgets.
Wow.
They talked about this content flywheel at GTC. Easier creation leads to more content, more engagement. It could really democratize filmmaking.
Interesting. might disrupt traditional ways, but opens doors for smaller creators.
Exactly. New ways to tell stories, new voices potentially getting heard.
And Jensen Huang kept talking about physical AI, robotics. He threw out a huge number.
$50 trillion. He estimated the market potential for physical AI and robotics at $50 trillion.
50 trillion. Why so high?
Well, partly addressing labor shortages. There's a projected shortfall of 50 million workers globally by the end of the decade.
Okay, that makes sense. Automating physical tasks.
Right. Repetitive tasks, dangerous tasks. And NVIDIA just announced Isaac GR00T N1. It's like a foundation model for humanoid robot reasoning.
Yeah.
Open, customizable.
A foundation model for robots, like large language models, but for physical action.
Kind of, yeah. Helping robots understand and interact with the physical world more intelligently. And companies like Neurorobotics, 1X Technologies, Vention are already using it. Shows the demand is there now.
And this connects to their Omniverse platform, right? For training robots virtually.
Exactly. Isaac Sim, it's crucial. Train the robots in these realistic virtual worlds first. It's faster, safer, cheaper than just trying things in the real world.
Lets them learn and adapt quickly in simulation before they, bump into real things.
Precisely. Drastically speeds up development and allows for testing all sorts of scenarios.
We even saw AI and robotics in art. That breakfast piece, consumption at GTC, using real-time data to move a sculpture.
Yeah, fascinating stuff. It just shows how versatile these tools are, from heavy industry to fine art.
Okay, so amazing progress, incredible potential. But we also need to talk about the flip side, the big considerations. Energy use came up.
It's definitely a critical issue. That International Energy Agency report, it forecasts power demand from AI and crypto could double by 2026.
Double. That's huge.
Equivalent to the entire electricity use of a country like Japan. Companies are working on efficiency, sure, but the sheer scale. Look at Google's Hamina data center. These things are energy hogs.
Yeah, that environmental footprint is definitely something we need to watch. And with powerful tech comes regulation.
Inevitably, searches for AI regulation are way up. Huge public and political interest in setting some guardrails.
Is that driven by lack of trust?
Partly, yeah. Public trust in AI is still pretty low in many places. Surveys show maybe only 30% trusted in the US, for example. Trust in AI companies is falling too. That definitely fuels the calls for regulation.
Right. People want assurance it's being developed and used responsibly.
Exactly. So you see things like the EU's AI Act, the US executive order, governments grappling with safety, transparency, bias, ethics.
And international efforts too, like those AI safety summits.
The AI Safety Summit, the Seoul Summit, trying to get global cooperation because AI doesn't really respect borders.
Okay, another distinction Jensen Huang made was between reasoning AI and basic pattern matching AI.
Right. He used NVIDIA's R1 versus models like Llama 3 as examples.
And NVIDIA is releasing an open source reasoning model, part of their NIM system.
Yeah, enterprise ready. It signals this move towards AI that doesn't just recognize patterns, but can actually, think, break down problems, consider steps.
That feels like the next big leap, beyond just prediction.
It really is. AI that can tackle more complex tasks, make more informed decisions, making it open source could speed up innovation too.
It's still kind of wild how these generative models work, though, just predicting the next word, essentially.
Right, but through these incredibly complex calculations.
They produce stuff that seems so intelligent.
Yeah, and honestly, even the experts don't fully grasp every intricacy of how they arrive at their outputs. The complexity inside these neural networks is just immense.
Okay, so wrapping up this deep dive, we've covered a lot of ground.
We really have.
The incredible pace of hardware advances.
Yeah, the chips, the scale up.
The ways AI is transforming industries' work, software dev, healthcare. Huge changes there.
Definitely. And that whole new field of physical AI, robotics, just getting started, but massive potential.
Right. And we hit on the big picture, too, the energy concerns, the push for regulation, building trust.
Critical issues and the constant innovation like we saw from GTC. It just shows how dynamic this whole field is. It's not standing still.
For a second. Which leads to, I guess, our final thought for everyone listening. With AI getting so capable, so integrated, what are the biggest societal shifts we really need to start anticipating and preparing for?
Yeah, it's not just about our jobs, is it?
No, it's the broader stuff too. The ethical questions, the economic impacts, the environmental ones we talked about. Definitely something to keep thinking about as this all keeps evolving.
Absolutely.
And of course, we hope this sparks some curiosity for you to dig deeper into whatever caught your interest today.